right, guys, I ran into some people in the hallway and they were telling me that they were still confused about a couple of things for your exam tomorrow. And one of those big things was nonpolar versus polar. So I'm going to make this quick thing to show you again what the difference is between polar and nonpolar. So first, you have to figure out if a bond is polar. The way you figure out if a bond is polar is if they have different electronegativities, then basically the bond will be polar. Electronegativity increases on the periodic table. That's my periodic table, by the way. Electronegativity increases in this direction, and basically it's over and up. Fluorine is the most electronegative. Some other common things, particularly for organic chemistry, carbon and oxygen is absolutely a polar bond. Carbon sulfur is polar. Carbon double bond to oxygen, that's a polar bond. Carbon to any of the halogens, those are all polar bonds. For organic chemistry, the important thing is that there is no electronegativity difference between carbons. They're the same. There's no electronegativity difference between carbon and hydrogen bonds. So these guys here are nonpolar because they have the same electronegativity. So for example, I think that what we were talking about in class last time was fatty acids. So here's like a fatty acid. It's got a carboxylic acid end and then a whole lot of carbon bonds. So down here in this end, all of this portion of the molecule is absolutely nonpolar. It's nonpolar because they're all carbon-carbon or carbon-hydrogen bonds. But this end of the molecule is polar. It's polar because oxygen is more electronegative, so it pulls the electron density to itself. And the oxygen is more electronegative, and it pulls the electron density towards itself. So this fatty acid basically has two ends to it, a nonpolar end and a polar end. The nonpolar end is insoluble in water. The polar end is soluble in water because like dissolves like. Water is a polar molecule. It's polar because it has two polar bonds. Oxygen pulls the electron density to itself. Oxygen pulls the electron density to itself. So water is polar. So things that are polar should be soluble in water. Things that are nonpolar should be insoluble in water. Now that we know that, we're going to redo the intermolecular forces chart. So the first question that you ask yourself is polar versus non. If the molecule is nonpolar, then the strongest intermolecular force present between two of those molecules will just be the London. If, however, the molecule is polar, then you ask yourself, is there an H bonded to FO or N? If there is an H bonded to FO or N, then the strongest intermolecular force present is hydrogen bonding. And if there is not, then the strongest force between two molecules will be the dipole-dipole. So let's say, for example, you have dichloromethane. This we used in the lab. You guys kept telling me that you couldn't figure out how to say it. It's just dichloromethane. So is dichloromethane polar or nonpolar? Dichloromethane is polar. Chlorine is more electronegative than carbon. It pulls the electron density to itself. Chlorine is more electronegative than carbon. It pulls the electron density to itself. It's not balanced out. It's not symmetric. They're both kind of pointing up. So dichloromethane is a polar molecule. What's the strongest intermolecular force? Well, we know it's got the London force because it's a molecule. It's polar. There's no H bonded to F or N, so the strongest intermolecular force present is the dipole-dipole force. Hexane for another example. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Hexane. So we're going to figure out if it's polar or nonpolar first. Hexane only has carbons and hydrogens. There are 6 carbons and 14 hydrogens in hexane. So since it's all carbon and hydrogen, it is a hydrocarbon and it is an alkane. It is nonpolar. So the strongest intermolecular force present is the London force. Carboxylic acid, on the other hand, polar or nonpolar? Absolutely polar. Not symmetric, so it is polar. Strongest intermolecular force present is a hydrogen bonding. Has hydrogen bonding because there's an H bonded to F over N. All right, so that was the first question. The next question that someone asked me about was shapes. So just real quick on the shapes that are the most important. You have linear. That's when you have 2 things around the central atom, things being atoms or lone pairs, and both of them are bonds. So really this is, and let me erase that because I don't like it. Linear is when you have 2 bonds to the central atom. So we're going to focus in, this is an alkyne, we're going to focus in on this carbon here. This carbon has 1 atom to the left, that's a carbon atom. It has 1 atom to the right, that's another carbon atom. So that central carbon has 2 atoms around it. Yeah, let me erase this again. We're going to just say 2 atoms rather than 2 bonds. 2 atoms around the central atom. That is linear. That has a 180-degree bond angle. Next up, you have trig planar. Oh, that's supposed to be a P. Trig planar. Trig planar is when you have a central atom that has 3 atoms around it. And its bond angle is 120 degrees. So again, we're going to focus in on this central carbon here. It's got 1 oxygen, 1 carbon, 1 carbon. So there are 3 atoms around the central carbon. 3 atoms, no lone pairs, is trig planar. Now we've got the tougher ones, okay? The tougher ones. You've got typical carbon, 4 atoms. That is tetrahedral. 4 atoms around the center. Bond angle of 109.5 degrees. So again, zoom in on the central carbon. You've got 1, 2, 3, 4 atoms around it. 4 atoms around a central carbon is tetrahedral, 109.5. Then you've got trig pyramid. Trig pyramid, the best example for it is ammonia. You've got 3 atoms and 1 lone pair. That gives you a bond angle of 107 degrees. So again, we're going to focus in on this nitrogen atom. It's got 1, 2, 3 atoms and 1 lone pair. 4 things in total, things being atoms plus lone pairs. 3 atoms, 1 lone pair, trig pyramid. And last but certainly not least, we've got 2 atoms and 2 lone pairs. That is bent with a bond angle of 105. 2 atoms, 2 lone pairs. So zooming in on that central oxygen, it's got 1 hydrogen, that's 2 atoms and 2 lone pairs bent. I hope that helps.